Hello everyone, I am Indrajyoti Gaine. I am presently a PhD student at Department of Mathematics and Statistics IIT Kanpur, and I am a PMRF fellow right now, and I have cleared my CSR net with 108 rank. Okay, so we are discussing about the trigonometric functions, and in the last class we have discussed about the sine and cosine function, and before that we have discussed how the measure of an angle with respect to radian measure and a real number is correlated. Okay, so by that case we have discussed that sine and cosine function can took all the real numbers, and we have studied the fact that sine and cosine functions, these are two functions which has domain R, and it has range -1 to 1. It has range -1 to 1. Okay, so we can consider this sine and cosine as a function, and these are called one particular example of trigonometric function. There are few more trigonometric functions, but these are some trigonometric function, and it can take any real number as a radian measure and of some angle, and it can give some real number between -1 to 1. Now, why -1 to 1? Because the range we have discussed in the earlier class, that from here we have discussed that the angle and the triangle from here, this red one I'm drawing in this particular portion here, A and B are correspond the things like this: cos x equals to A and sin x equals to B. And how we find that, those things we have already discussed from here. Okay, so from that thing we have discussed that A and B will be the sin x and cos x, and since the circle is of radius 1, so A can be vary from -1 to 1, and as B can vary from -1 to 1. That's why cos x and sin x can take values up to -1 to 1. This can give values from -1 to 1. Okay, and also we have checked things like this, where the sin x and cos x are 0 for some integer value n, and after that we have discussed one thing, that after 2 pi period every value of sin x will repeat. That is, for any value x, okay, it should be written here, any x belongs to real number, sin x plus 2n pi is equals to sin x. That is, the value of sine will repeat after t pi period. Okay, so that's why this function is called a periodic function, because it is giving the same value after a certain time or after a certain step, you can say. So that's why it is called a periodic function. So that thing is different, but we are not discussing here. So okay, now in the last class also we have discussed about the measure of sine 0, sine cos 0, sine pi by 2, cos pi by 2, and all those things. Now let us discuss another thing, which is sine pi by 4. Okay, sine pi by 4 or sine. Okay, no, okay, let's draw. So this is our axis, x-axis and y-axis, and this is the unit circle we have considered in the last class. Similar circle, unit circle. This must be a unit circle. Okay, this must be an unit circle. Now this is the point P, suppose A and B. So obviously this portion will be A, this will give us B, and this green part, this part will give us the radius of the circle, that is equals to 1. That should be equals to 1. I'm not writing that. Okay, this is O, this is our A, this is, okay, this is not A, this is our A, this is B, you can say. Okay, like this. Now here this is the angle x, which is measured in radian measure. Now if we have discussed about x equals to 0, pi by 2, 3 pi by 2 and 2 pi. Now what if x equals to pi by 4? Okay, so pi radian means 180 degree. This means pi by 4 radian means 180 degree divided by 4, that is equals to 45 degree. Now x equals to 45 degree. In case of if you measure this as a degree measure, then x 45 degree means this triangle, okay, this triangle OAP is in the triangle in AP, OA and AP will be same, that is same length. This implies A equals to B. Now as it is right angle triangle, we all know, so this can give us A square plus B square equals to 1, which give us 2A square equals to 1, which give us A equals to plus minus 1 by root 2, sorry, plus minus 1 by root 2. A equals to plus and minus 1 by root 2, which is again equals to B. Now since A and B are representing the length of some line, so this must be positive, because length can be negative. That's why we are eliminating this negative part. So A equals to 1 by root 2 equals to B. So from here, and in the last class we have discussed this thing. So we can clearly say cos x equals to, that is cos pi by 4 equals to cos pi by 4 equals to 1 by root 2, and similarly sin pi by 4 equals to 1 by root 2. Okay, so thus we can find the value of sin and cos for some particular values of x, and by this we can you can check that the value of the trigonometric function and the trigonometric ratios that we have discussed in the earlier classes are same. Okay, so from here we can get a table of the trigonometric function for sin x and cos x. So that will be like this. So we give the sin x, this will give the cos x. Now I am writing in the term of not degree, it should be radian. It must be radian. 0, pi by 3, no, pi by 6, pi by 6, pi by 4, pi by 3, pi by 2, pi, 3 pi by 2, and 2 pi. Okay, so majorly we should be aware of this part only, because other parts can be found from the graphical representation like this, from the drawings, and you can find the value of A and B, and from there you can find the value of cos x and sin x and all those things. So only majorly you have to focus on this part only, up to pi by 2. Okay, so the values are sin 0, this must be 0, and cos 0, 1, as we have discussed in the last class. Sin 0, 0, cos 0, 1, and similar was for trigonometric ratios, right? Now what about pi by 4? Both are 1 by root 2. What about pi by 2? This should be 1, this should be 0. What about pi? 0 minus 1. What should be this? 3 pi by 2 minus 1, 0. And this should be 0 and 1. Okay. Now, one can find the value of pi by 3 and pi by 6 by computing the value of sine 30 and sine 60. So, we are just writing those things. You can verify by the help of radian measure and converting this radian measure to the angle measure, that is the degree measure, and using the trigonometric ratio and value of that trigonometric ratio at that point, you can find this value 1 by root 2. This should be root 3 by 2, and this should be here root 3 by 2, and this should be 1 by 2. Okay. Just, and obviously notice that all the values should be repeated after 2 pi angle. After 2 pi angle, it should be repeated. Okay. Okay. So now we can discuss some more trigonometric functions. Okay. So using the sine and cos functions, we can define some more trigonometric function. So for that, first we will introduce the cosec function. What is that? Cosec of x, which is nothing but 1 by sine of x. Next is sec of x, which is nothing but 1 by cos x. Okay. Now third is tan x, which is nothing but sin x divided by cos x. And the fourth one is cot x, which is nothing but cos x divided by sin x. Okay. Okay. Now the thing is, the function, we must be aware of the domain and range of the function. So in the last class, we have discussed the domain and range, and also we have stated this statement that sine and cos function as the domain real number and the range is -1 to 1. The closed bracket -1 to 1. Closed bracket means it will attain the end values. Okay. So what about the domain for the cos x function and sine cosec x, sec x, tan x, and cot x? So obviously cot x, you can see that cot x is nothing but the reciprocal of tan x. Okay. And cosec x is the reciprocal of sin x, and sec x is the reciprocal of cos x. Okay. Now we all should know about this thing, that 1 by 0 is undefined, right? Now what about cosec 0? What about cosec 0? This should be 1 by sin 0. This means 1 by 0, and which is undefined, right? So from here we can clearly see that we have to eliminate those x values from the domain of cosec x where the sin x is 0. Okay. So where sin x is 0? Sin x is 0 at these points. At these points, or sorry, not this point, this point, sorry. I have noticed the wrong position. These points. So all in pi. So this function must have domain that should be r minus n pi. N pi means set of all integer multiple of pi. Okay. Okay, not couldn't erase this part. So maybe okay, it's erased. So domain should be real number minus n pi, where n is any integer. It can be any integer, and the domain. What should be the domain? So sin x has domain 0 to 1, right? Sorry, sin x has range 0 to 1. Sorry, minus 1 to 1. Minus 1 to 1. Now, what about 1 by sin x? So, whenever sin x is less than 0, greater than minus 1, less than equal to 0, should not say. So, less than 0, greater than 1, this implies 1 by sin x. This is less than equal to minus 1, greater than minus infinity. And when if sin x is greater than less than equals to 1 but greater than 0, this implies 1 by sin x is greater than equal to 1 less than plus infinity. Less than plus infinity. Okay, so one can clearly see that for the domain, if I consider for the domain, not for the domain, for the range of sin x, the 1 by sin x lies in the interval this or this. Okay, and whatever we have eliminated from the domain of this, like I have eliminated the n pi's. Now n pi are the point where sin x can attain 0. So whenever we eliminate the n pi's from the real numbers, then sin x will not attain the point 0. Okay, so we should not be aware of the point 0. It should not be bother about that point. So either case will be this. One case can be this, when sin x is strictly less than 0. Another case will be sin x is strictly greater than 0. And for both cases, we found these are the resulting condition or resulting domain. Okay, so therefore one can say that the range of cosec x should be the union of two sets. Which two set? One is minus infinity to minus 1, union 1 to infinity. This is the range of this function cosec x. I am rewriting it because we have space there. Minus infinity to minus 1, union 1 to infinity. Okay. Similarly, for sec x, the domain should be what? Minus n plus 1 pi by 2, where n belongs to integers. Integers denoted by z. Okay. Because of this fact. Okay. Okay. So what will be the range? The range should be similar because of the same thing that cos x lies between minus 1 to 1, and we have eliminated those points where cos x can be 0. So obviously by similar way, range should be minus infinity to minus 1, union 1 to infinity. 1 to infinity. And why we are putting open bracket for the infinity portion? Because this is that for denotion that the range, the domain, the range should not be some finite value. It will give some arbitrarily large value. Okay, infinity we are not including because infinity is not a number. It is just a notation that it will be enough large to be imagined. Okay. Now what about tan x? So obviously the problematic points must be the cos x where the cos x is 0. So the domain should be obviously this thing, 1 pi by 2 where n belongs to the integer set. This must be the domain. This must be the this must be the domain. Now what about range? So whenever we have sin x by cos x, so just check these things. Tan x can be written as multiplication of sin x and cos x. Sorry, sin x and sec x. Right? Now sec x has a range from minus infinity to minus 1 and 1 to infinity. And sin x has a range from minus 1 to 1. Right? So if we can choose a particular value, then we can clearly see that, okay, how to understand this thing difficult. Okay, cos x can be written like this. This is the domain of 1 by cos x. Okay. Now tan x have range, tan x has domain this because of the zero value of cos x. Now what about the range? So the range can be like this. Just check tan x. This is equals to sin x divided by cos x, which is nothing but sin x into sec x. Okay. Now sec x has value. This has value. It can give the value from minus infinity to minus 1 union 1 to infinity, and this can give the value minus 1 to 1. And there are few positions where you can see that whenever sin x is 0, then cos x is 1, and whenever cos x is 0, then sin x is 1. Like this kind of thing are happening. And now in the case of tan x, we are eliminating those points where cos x can be 0. So cos x cannot be 0, but sin x can be 0. Right? Cos x cannot be 0, but sin x can be 0. And one can later on one can check that, or one can see. I will explain something that this both the functions sin x and cos x are periodic, and tan x is also periodic. Okay, tan x will also assume some values repeatedly after some pi times. Okay, integer multiplier pi times, it will assume same values. So by that thing, it will give all the real numbers. So the range of this set tan x must be the real number set. Okay, this must be the real number set. You can check that why this is 0. Like if you take x equals to 0, then sin 0 is 0 and cos 0 is 1. So it will give me the 0. Now if I increase the value from 0 to very small portion, then sin x will give some value between minus 1 to 1, and cos x will not give much distance from 1 or minus 1. Okay, like 1 by cos x, that is sec x, will not go far away from minus 1 to 1. Okay, so by that process, it will give the values between minus 1 to 1, 2. So by that thing, we can say that tan x has range the whole R. And later on, when we will draw the graph of tan x, we can again see that it has given all the real numbers. It will give all the real numbers. Okay, and similarly, cot x has domain what? R minus n pi, where n belongs to the integers, and the range set should be R, the whole real number set. Okay, so thus we can define the other trigonometric function, and whenever we are discussing about any function, we must be aware of the range of this domain and range of these functions. So thus we have discussed all the domain and range of other 4 trigonometric functions. Now, in the last class, we have discussed about this fact, and we already know this fact that sine square x plus cos square x equals to 1. Now, whenever tan x exists, tan x is well defined, in that portion cos x should not be 0, right? Whenever tan x is well defined, then cos x must not be 0. So cos x is non-zero means we can divide this whole equation by cos x in that range, in that domain. So that will give us sine square x divided by cos square x equals to 1 divided by 1 by cos square x. This is giving us tan square x plus 1 is equals to 6 square x. Okay. And similarly, there are some domain where sin x is not equal to 0. So we can divide by sin x and get a formula for cot x. And that is nothing but 1 plus cot square x equals to cos square x. Okay, just divide by sin x and you can see why we are getting this formula. Now we will go to the next section where we will discuss about the sign of the trigonometric function. Sign of. Okay. So before going to this section, we should recall one fact that we know that sine function is sine and cos function both are positive in the first quadrant, and sine function is negative in the second quadrant, cos function is positive. Like these things we have discussed earlier. Whenever we have discussed the ratio of this sine and cos as a ratio, trigonometric ratio. But now we will discuss about the change of the sign and when it will change and when it will not change, all those things with respect to the trigonometric function. Okay, for all trigonometric functions. So whatever we have discussed here, so we just need to bother about what is the change in sign for sin x and cos x. Others will give us automatically. Okay, others things we will get automatically. So we just need to bother about what is the case for sin x and cos x. So again, draw the diagram x and y quadrant, and this is the unit circle. P be any point on this circle. Now this is the unit distance, which is the radius of the circle. Okay. Now this is the portion A. This is B. Okay, and this is the angle X. This is the angle X. Now we know sin x equals to B and cos x equals to A. What about this point? If the point is at this point B, so what is different? A should be same, but B has changed. So B should be minus B. Why minus B? Because if we are considering this is along the negative y-axis, so obviously distance should be minus B. What about this portion? This should be same because this is positive R. So 1 radius of the unit circle. So this must should be 1. So what about the coordinate of the point B prime? That should be A, minus B. What about this thing? So whenever we go along the anti-clockwise direction, then it is positive. So this must be negative. So this should be minus X. Okay. Why this is? Because we are going along the negative, clockwise direction. Okay, and we have started from the OX axis and we have arrived at the point OP dash, and since the rotation is along the clockwise direction, therefore we will take the negative side. Now from here, from the triangle OP dash A, you can say this A point, OP dash A, one can clearly say that sine of minus x equals to minus b, and cos of minus x equals to a. So from here one can clearly say that sine of minus x equals to minus sine of x, and cos of minus x equals to cos x. Okay, that's why we say that cos function is an even function, because cos of minus x is again giving us cos x, but sine of minus x is giving us minus of sine x. That's why it is an odd function. So by the definition of even function and odd function, we can say that cos function is an even function, but the sine function is the odd function. Okay, now we are just before sometime before we have discussed that sine function and cosine function are positive, negative, and all those things in some quadrant. So let us discuss what about the other quadrant. Okay, so this is the fourth quadrant. So for up to go up to fourth quadrant, you have to be go 3 pi distance, 3 pi by 2 distance, and after that we will arrive at the fourth quadrant. So one can say that minus x is nothing but 3 pi by 2 plus 2 minus x. Or you can say like this, minus x equals to 3 pi by 2 plus pi by 2 minus x. Like this, it will be minus x. Okay. Okay. So if I know about this thing, then we will know about other things, and we can go up to those part. So before that, we should be aware of like this. Okay. From here, one can say that this is a different section. One can say that this minus equals to this. So here you can see that this minus x is in the fourth quadrant. This is in the fourth quadrant. Why it is the fourth quadrant? So whenever one have to arrive this minus x angle, so he have to first cover in the positive direction, like in the anti-clockwise direction. He have to first cover the 3 pi by 2 distance. He have to rotate 3 pi by 2 distance. After that, he will arrive at the point. You have to go again pi by 2 minus x distance. Then he can go at minus x point. Okay, so sine of minus x, this is nothing but like this, sine 3 pi by 2 plus pi by 2 minus x. Okay, so in the third quadrant, what about the fourth quadrant? We can say for the fourth quadrant, sine is giving us the negative value, and cosine is positive. Okay, so what about this portion? What about this p dash point, p double dash point? Okay, so here one can see that a is negative, but the b is also negative. Both are negative. Minus a minus b. Okay, this is the axis which is distance 1. So what about this point? If this we have not angle is x here, so what about this angle? The angle will be pi plus x, right? From here it will be pi plus x. So what about sine pi by x? Sine pi by pi x, pi plus x equals to minus a, which is nothing but minus of sine x minus b, and cos pi plus x equals to minus a, which is equals to minus of cos x. Okay, so from there you can see that sine function and cos function are both negative in the third quadrant. What about second quadrant? So you have to go up to second quadrant if you cover the distance pi by 2, and after that you have to go some x distance which is between 0 to pi by 2 value. Okay, so you have to go like this. So let us draw that picture again here, that you know how to get some difficulty. So whenever you are in the point P is equals to something. So let us study what is this point. You have to go in the along this direction. So you have to go along negative real axis but positive y axis. So this should be B minus A comma B. This is the point of this is the location of the point P. And what about this angle? This angle is, what about this angle? This angle nothing but pi minus these things, right? So from there, if we consider this as not like that. Okay, right. X and Y. This is the unit circle. This is the origin. This is even the point P. This is our, okay. This is the point minus A. This is our B. This is the point P minus A comma B. And what about this? This is the angle pi by 2 plus x. But what about this thing? So this is theta. So we know about the sine theta, which is nothing but sine pi minus pi by 2 minus x, which is giving us sine pi by 2 minus x. And okay, we can discuss this thing later because we need to use the formula, and we can then from there we can understand this geometrically. But just understand these things like about we are denoting these things, not like that. The main concept is we are measuring the angle from here. We always measure the angle from here, not from here. So that's why whenever we are in this quadrant, we must be consider this angle, and using this angle we will consider this angle, and from here we will find sin x and cos x, and we will find the angle of the this thing. We can find this thing. Okay, from there we can find, okay, that can also be find from here. If we consider this as pi by 2 plus x, then what about this angle? This angle will be pi minus pi by 2 plus minus x, and this thing will be this thing, and this is given by our minus a and b. So that should be minus that should be plus b, that should be plus b, and this is given by nothing but, okay, not like this. This is our minus a, this is our b, this is the point P minus AB. And what about the angle? Sin pi by 2 plus x. This is the distance means pi minus theta, and we have to use the angle formula like sin pi cos theta plus cos pi sin theta, and clearly this sin pi is 0, cos pi will be minus 1, so minus sin theta like this we can find this thing. So we will not discuss this thing here because it will be little confusing, because we have used this formula, we have not discussed this formula here. So that's why we are not discussing here this thing. But yeah, one can find this thing like sin pi plus x and cos pi plus x value, and that this thing will give like similarly this way. Using the length of a and b, we can easily find these things. Now, depending on these things of all the sine portions, one can easily find the table of positive and negative in the book of NCERT, and one can go through that when the sin x and cos x and all the other trigonometric functions are positive and negative. I am not writing those things here. What about now? We have discussed about the sign of sin x and cos x. Now, what about the sign of cosec x and cos x and tan and cot? So, where the sine function is positive, clearly the cosec function is positive. Where the cos function is positive or negative, depending on that, sec function will be positive or negative. What about the tan x? Tan x will have the negative sign when sin x and cos x has opposite sign. If they both have same sign, then tan x is positive. Like if sin x and cos x both are positive, then tan x is positive. If both are negative, then tan x is negative. If either is negative, like sin x is negative, cos x is positive, or cos x is negative, sin x is positive, then also tan x is negative. Okay, and since the cot function is the reciprocal of tan function, therefore that function will also follow the same rule. It will similarly be positive and negative depending on the sign of cos x and sin x. So up to this thing, we are clear that we are very much dependent on the sine function and cosine function, and depending on these two functions, we can clearly say that when the other trigonometric functions has positive value or negative value. Okay. Now you can if you see these things like now check that if x increases from 0 to pi by 2, what is happening in the case of sine function? Okay, so x is increasing and x is increasing. So at the point sine x, it is sine x equal to 0. So sine function will be 0. So if x equal to 0, then sine x 0, x equals to pi by 4, sine x is 1 by root 2, and if x equals to pi by 2, then sine x equals to 1. So whenever x is increasing from 0 to pi by 2, sine x is also increasing. Okay. Similarly, whenever this x is lies between pi by 2 to 1, pi by 2 to pi, then sine function is decreasing. Okay. So just check here. You can write arrow. X goes to 0 to pi by 2, then sin x goes to 0 to 1, then x goes to pi by 2 to pi, then this 1 again goes to 0. This sin x again goes to 0. Now again pi goes to 3 pi by 2, as x goes from pi to 3 pi by 2, then sin x goes to 0 to minus 1, and whenever x goes to 3 pi by 2 to 2 pi, then also this sin x goes minus 1 to 0. Like if I draw the thing here, we are just bothered about 0 to 2 pi. Why we are bothered about 0 to 2 pi? Because after this, all the values will be repeated. Okay, so whatever we are getting in this portion, we can repeat this portion up to infinite times. We will get the answer for other portions. Okay, that's why we are bothered about 0 to 2 pi. So if this is the one portion, this is the range where 1, and this is the range where -1. So the graph of the function cannot be exceed these two portion. So it should be remain under this portion. So whenever 0 to pi by 2, so here it can be pi by 2, here it is pi, here it is 3 pi by 2. Okay, now 0 to pi by 2, it is going 0 to 1. 0 to 1. After it is going to 1 to 0. 1 to 0. Now again after that this is going to 0 to -1, and after that this is going to again 0. Okay, so if I repeat this thing up to infinite times, we will get like this. This is the x-axis, which is representing the radians. This is the y-axis, which is representing the range of the sin x function, like y equals to sin x. So graph should be like, and so you can see clearly that it is a wave. This is forming like a wave, and this is a periodic function. So after each 2 pi distance, you can see the values are same. Okay, now what about the cos x? So for cos x, whenever x is increasing from 0 to pi by 2, then cos x is decreasing from 1 to 0. And one can clearly see this increment and decrement of this cos and sine through the geometry, or through the value of a and b. Whenever this x is increasing, this point, this rotation is going on. This p is going from a to the some along this y coordinate. Okay, so in that case, sin x, that is the value of b, is increasing, but the value of a, that is cos x, is decreasing. Right? Like, just compare these two things. Okay, we can draw here. Here only you can draw. You can draw two graphs. This unit circle. This is the point P. So in that case, the A should be this A. This is B. This is A. Now we are rotating, right? So next portion will be here in green. So this is the B and this is the A. So obviously you can say that A is getting smaller and B is getting bigger, right? Also, if we cross the distance pi by 2, so we are in this quadrant, then you can see that whenever we are increasing the value of x, then A is increasing, B is decreasing. That is, the cos is increasing, sin is decreasing. Same thing is happening in this portion also. Okay, so from this point of view, we have studied all these things. Okay, we have studied all these things. So similarly, for about cos x, so 0 to pi by 2, you can see that A is decreasing, so cos x is decreasing from 1 to 0. After that, pi by 2 to pi x, then cos x is going to 0 to -1. No, not 0 to -1. This should be 0 to -1. Then pi to 3 pi by 2. Then again -1 to 0. this cos x will be minus 1 to 0, and after that 3 pi by 2, 2 pi, then 0 to again 1. So if I plot, what I will get, this is the 0 and this is the 2 pi. So we will get like this. Okay, yeah, you can get this thing. So starting from 1 and ending at 1, and if I repeat this thing, what I will get, we will get like this thing. This we have repeated that portion again and again, like you can clearly see from here to here it is one section, then from here to here it is another section, from here to here it is another section. So we just joined the copies of this segment. We have copied and pasted like this. We have done these things and we obtain this graph of the function. And depending on the value of a and b and its increment and decrement, we have drawn all these things. And depending upon the range also, because it will not exceed the range value minus 1 to 1, and it will attain the 0 at every integer multiple of n pi and like n pi and 2n plus 1 pi for cos x and n pi for sin x. Like all the property will be followed, and after that we have, if I draw the curve, it will give us this curves. Similarly, depending upon this increment and decrement or this sin x and cos x, one can think about the cosec x, sec x, tan x, and cot x, and then one can draw the graph of these functions similarly, because whatever will be happen depending on that will be depend on this cos x and sin x. So in the next class we will study how this graph of cos x and sec x will look like, and how we can draw those curves depending on the value of a and b. Depending upon the value of a and b. Okay, and after that we will go with the graph of tan x and cot x, and how it will look like, and after that we will go to the formula of this formula. We have stated this thing, we have used this thing. I have not used these things today, but we have just, for some reason we have just stated these things. So we will study these things in the next class, and what are the formula of sin x and cos x, or what can be the formula and for the addition of two angle, and after that what can I do with these things, we will study in the next class. Okay, let's end here.